Topic 4 is about the metals and reactivity series. So remember that reactivity series is the arrangement of metals according to their reactivity. As you go higher up in the reactivity series, the metal is more reactive, and as you go down, the metal is less reactive. Um, to memorize this, remember that elements from group 1 and group 2 and group 3 are above carbon in the reactivity series. And we have carbon and hydrogen, which are non-metal in the reactivity series. And this is important because elements which are more reactive than carbon, which are above a carbon in the reactivity series, cannot be extracted from their metal ores using carbon because they are more reactive than carbon. And metal below carbon in the reactivity series can be extracted from their metal ores using carbon. Hydrogen is important as well because metals which are above hydrogen in the reactivity series, as we can see here, they can react with dilute called acids, while metals which are below hydrogen in the reactivity series will not react with dilute called acids. The reaction of metals with waters. Some metals can react with water to give you metal hydroxide and hydrogen. This is important to know this equation, the word equation, and also the equation with how to write the equation, the molecular equation with the state symbol. Hydrogen here is going to be a gas, and the metal hydroxide is going to be aqueous. Water is liquid, and the metal is solid. And then reaction of metal with acids. So acids, metals which are above hydrogen in the reactivity series can react with dilute called acids to give you salt and hydrogens, while metals which are below the metal in the reactivity, below the hydrogen in the reactivity series will not react with cold dilute acid, but they can react with hot acids or concentrated acids, like copper, for example. The redox reaction is the reaction where you can find oxidation and reduction in the same reaction, because when one element is oxidized, another, or when one substance is oxidized, another one is reduced. In terms of losing and gaining electrons, oxidation is loss of electrons. So any element that loses electron will be oxidized, and any element that gains electrons will be reduced. How to write the redox equation. There are three main type of equation where we can see or three types of reaction where we can see these redox reaction, and we can write the redox equation for. The first one is reaction of metals with acids, like iron with hydrochloric acid. That will give us salt with, which is iron chloride and hydrogen. Now you have to know how to write the half ionic equation and the ionic equation. The half ionic equation will only show the oxidation alone or the reduction alone. So here iron was oxidized because it lost two electrons. So iron gave you the ion and the electrons, and the hydrogen ion here from hydrogen chloride has been reduced because it gained electron to give you the hydrogen gas. The ionic equation only deals with the ions that has been oxidized or reduced. So you don't use the electrons here, and you don't also use the spectator ion, which is the ion which has not changed, like chloride here in this equation. Also, hydrogen displacement reaction is the same. It's one of the redox reaction, chlorine with potassium bromide, where the bromide has been oxidized because it lost electron. Chlorine has been reduced because it gained electron to give you the chloride, and this is the ionic equation. And also metal displacement reaction, the more reactive metals will displace the less reactive metals from their salts. So if you react iron with copper sulfate, because iron is above copper in the reactivity series, so it's more reactive, it can displace the copper from its salt to give you iron sulfate and copper as a metal. Then iron here has been oxidized because it lost electrons, and the copper has been reduced because it gained electron. Again, this is the ionic equation. All what you need to know about electrolysis. So electrolysis uses electricity to generate a chemical reaction. In electrolysis, you have two electrodes, negative and positive electrode, and you have a source of electricity. You have electric current here, and the two electrodes have to be immersed in an electrolyte. The electrolyte can be either a molten ionic compound or it can be aqueous solution of ionic compound. Remember that solids of ionic compounds can not be used as electrolyte because the ions are not free to move in the solid state. They have the giant ionic lattice, so they cannot carry the charge and they cannot be used as an electrolyte. What happens in the during electrolysis? So the electrolytes contain negative and positively and negatively charged ions which can move. So the positively charged ions will move towards the negative electrode where they become reduced as they gain electrons, and then the negatively charged ions will travel to the positive electrodes and they become oxidized because they lose electrons. Electrolysis of molten ionic compound, as an example, is sodium chloride, where you have the two electrode, positive and negative. The chloride here has this is molten ionic compound. So the chloride has the negative charge, so it moves to the positive electrode, and chloride here loses the electrons, so become oxidized to give chlorine. The sodium, on the other hand, has a positive charge, so it moves to the negative electrode, and it become reduced because it gains two electrons. One of the common exam questions is to ask you about the electrolysis of aluminium to extract aluminium from its ore, which is aluminium oxide. So in the extraction of the aluminium oxide to extract aluminium from its ore, which is aluminium oxide, first thing that you need to know that for electrolysis here, we use molten aluminium oxide. However, aluminium oxide has a very high melting point. This is why it's mixed with cryolite, because cryolite will reduce the melting point of aluminium oxide, and then less energy will be needed to melt it to get the molten aluminum oxide, and this will reduce the overall cost of the process of electrolysis because electrolysis is a very costly process. Now the electrode we use is graphite. So we use graphite here as electrodes. We don't use metals. What happens in the reaction is that aluminium moves toward the negative electrode where it become reduced to give you the aluminium metal, and the oxygen moves toward the positive electrodes and become oxidized because it loses electron. Because the electrodes here are formed of graphite, which is basically carbon, the oxygen that is when it moves to the electrode, it can react because oxygen is produced. Oxygen can react with the negative with the positive electrode to give carbon dioxide. So this positive electrode needs to be replaced continuously. What about electrolysis of aqueous solution? In aqueous solution, you have a different situation here because you not only have the ions from the metal from the ionic compound, but also you're going to have hydrogen and oxygen ions from water. So there will be competition at the negative and positive electrode. So at the negative electrode, there will be competition between the metal, which is the sodium in this case, if you have sodium chloride, and the hydrogen from the water. So you need to remember this. If the metal is above hydrogen in the reactivity series, then hydrogen is the one that is going to be reduced at the negative electrode. So you're going to end up with hydrogen gas at the negative electrode. But if the metal is below hydrogen in the reactivity series, then the metal is the one that's going to be reduced to give the metal. So if it's copper, copper is below hydrogen, so the copper will be reduced at the negative electrode. At the positive electrode, there is a competition as well between the anion and between the hydroxide from water. So if this anion is one of the halides, which is chloride, bromide, or iodide, then the halide is the one that's going to be oxidized at the positive electrode. So you end up with one of the halogens, either chlorine, bromine, or iodine. But if it's any other anion, then the hydroxide is the one that is going to be oxidized, and the product here is going to be oxygen. So remember, either halides or it's going to be always oxygen if it's not halide. So halides will give halogens, and then if it's any other like if you have anything like nitrate, like sulfate, anything, any other anion, then it's always going to be oxygen. Acid-base topic. So first of all, the pH indicators. You have the universal indicators, which gives a range of colors at different pHs. So it's not suitable to be used in titration. While we have the sudden color change indicators, and these are the three indicators that you need to know for your exam: litmus, phenolphthalein, and methyl orange. And you need to memorize the color change at the acid and alkali solution. These will give you a sudden change or distant color at the neutralization point or at the end point for the titration. So they are best used for titration. The difference between acid bases and the different pHs. So acids will ionize in water or in aqueous solution to give you hydrogen ion. The pH of the acidic solution is less than 7, and lower the pH, the more acidic the solution. Sometimes they give you a change in the pH and ask you to calculate the change in the hydrogen ion concentration. So remember, in reduction in the pH leads to an increase in the hydrogen ion concentration by a factor of 10 to the power n. So if pH changes from 5 to 3, the hydrogen ion concentration increases by 10 to the power 2. For bases, bases react with acid as a definition. So bases react with acids to give salt and water. Examples of bases are metal oxides, metal hydroxides, and metal carbonate. The pH of alkaline solution will be more than 7. Remember the neutralization reaction, which is the reaction between acid and base to give salt and water. The very common question in the exam to ask you to write the neutralization ionic equation, and this is the neutralization ionic equation where hydrogen as aqueous react with OH as aqueous to give you water as a liquid. So this is the ionic equation for the neutralization reaction. The difference between strong acid and concentrated acid is a very common question as well in the exam. So acid strength refers to whether the acid is fully or partially ionized. So strong acids fully ionizes in aqueous solution to give hydrogen ion, while weak acids only partially ionizes in water or in aqueous solution to give you the hydrogen ion. So it's not fully ionized. While when we talk about concentration, acid concentration, whether it's concentrated or diluted, we are talking about how much of the acid is there. So concentrated acid contains more of the acid in the solution, while dilute acid contains less of the acid in solution. The formation of soluble salts is a very common question as well, where they ask you to describe how you can form a soluble salt. So there are 3 steps in this method. The first step is to add an excess of insoluble base to an acid solution. And when the bases you can use here, you need to use insoluble metal oxide, insoluble metal hydroxide, or insoluble metal carbonate. These are all insoluble bases. The second step is to filter the excess insoluble base. The third step is to crystallize or do crystallization of the filtrate and to get